So today's topic, I will continue with the image formation using lenses. In the last video, the previous video, we have come across the image formation rules for the lenses, like what are the rules which takes place when the light ray is traveling parallel to the principal axis, what happens, and when the light ray travels through the optical center without refraction, it passes. Then one more thing was, when the light ray is made to pass through the focus, it travels parallel to the principal axis without undergoing refraction or without undergoing bending. Yes, so these rules will make use of those rules and understand how the image is formed in lenses using the ray diagrams. You have already studied about this in the mirrors, correct? No, we have already studied about the image formation in mirrors using ray diagrams. It's the same way, exact same way, we are going to make use of the ray diagrams and understand the image formation using lenses. Okay, let's begin with the first one. First, I'm always dealing with the convex lens. Okay, and that is in the all the diagrams, whatever I've drawn, is of the convex lens. I'll tell you all when I'm going on to the concave lens. So first, initially, the major important topic which you need to know in this chapter is the ray diagrams of convex lenses. Okay, image formation using convex lenses. So the first type of observation we are going to make is using a convex lens. So I'll give you a rough idea of how to start drawing this type of a diagram. So first draw a straight line, just like that, straight line. Then draw the centermost point of that straight line and name that as optic center. Okay, draw a straight line and draw a centermost point of that straight line and mark that as optic center, or O, just O. Same as that of your number line drawing. So then draw a lens. Like if it is convex, you draw a convex lens. If it is concave, draw a concave lens. Okay, so a little of equal amount of gap. You need not use scale or measure the distance, nothing as such. So just take a distance, like any distance, like equal distance in your sentence you take. And in a paper or sheet of paper, you simply take a distance from O point to some point. Some point. You just take it as some point. Another equal distance you mark it like. Okay, same way you do it in the other side as well. Equal distances to this side. You remember how we have done it in the number system, but do not mark it very close. Very close, if you mark, it is not wrong, but the diagrams will be congested, which you will not end up understanding it clearly. So make a sufficient amount of distance in the diagram, probably around 3 centimeter gap, but it is not necessary at all. Okay, so remember, these distances gap should be equal. Need not measure again, just roughly equal. It should not look like one is here, another one is somewhere here. Okay, this is wrong. So remember, it should be of equal distance. All the distances are of equal, like right side of that lens and to the left side of the lens. And this distance, O to one more, first distance, I will mark it as focus. That is F, and this side also F. So you can mark this one as 1 and this one as 2, or this as 1 and this as 2. It's up to you. It's not anything like you need to measure, you need to mark this as 2 and 1 or 1 and 2, nothing like that. So you just mark it as one as F1 and one more as F2. One more is twice that of this distance, right? Twice that of distance. So I will mark it as 2F2 to this side, and this one I will mark it as 2F1. And this 2F1 is nothing, F2 is nothing but center of curvature. This is center of curvature of this side. Okay, so this is the basic idea for drawing that particular diagram. To start with the diagrams. Okay, remember, these distances should be equal, and this center point O should be clearly visible. That is, optic center should be clearly visible, and type of a lens should be clearly mentioned, whether it is convex lens or the concave lens. Fine. So this one, I'll move on to the first diagram. So understanding drawing the diagram, I have explained you all what to do. Please follow the procedure exactly. And the first one, let us assume that a big convex lens is in front of me. Okay, big convex lens, a big huge convex lens which is of my size is right in front of me, and I'm moving very far away from the lens. That is, I'm going to the position of infinity. I'm moving far away from the lens here. Far away from the lens, that is, I am the image, or the person over here is position of the object. Okay, that person is the object. So he is moving away from the focal length, that is very far from the lens, which means his position is at infinity. The position of the object is at infinity. So from there, the infinity, the light rays will always travel parallel. I have already told you all that whenever a source of light is coming from the infinity, that is from very far, the light rays are almost parallel to the principal axis. Okay, remember this concept and understand here. When the light is coming from an object which is far away, that is infinity, all the light rays will travel parallel to the principal axis. And when these light rays travel to the principal axis parallelly, and they fall on the convex lens. You know what does a convex lens do? It all converges all the light rays and make it fall on a one point. That is, it will converge and it will be pointed onto one point, and that point is called as the focus point of this convex mirror, and we have already studied. So that means what is happening here is the object person is very far, and all the light rays are traveling parallel, and then it is getting converged at a point, that is focus point, and there the image is formed of this object. So the position of the object is at infinity, then the position of the image formed is at focus. Mention it where it is at f2. Suppose in your diagram you have marked it as f1, write it as f1, simple as that, no confusions at all. So the image is formed at the focus, and what is the size of the image? So where I am writing it as relative size, which means it is the size with respect to the object, the size of the image with respect to the object. That is the meaning of relative size of the image. So relative size of the image is highly diminished, that is very small, highly diminished, very very small, or point sized. Okay, so the same case was happened in the mirror as well. That's it. When the image is formed at the focus point, it is all the light rays are converged and it is going to form a point sized image, or in other words, highly diminished image. And then what is the nature of the image? Actually, the nature cannot be determined because it is just a point, but it is better for us to understand, because in the textbook they have given it in this way. It is real and inverted. Please, whenever you are writing in the exam, write it as it is in the textbook, so that you do not have any kind of confusions with the board. So as it is, write it as real and inverted. Though practically we can say that the image type, or what type of image is it, the nature of the image will not be determined, but according to your textbook it is real and inverted. Write it as it is. Okay. So these are the details of my first diagram. I'll move on to the second diagram. In the second diagram, you can see that the object is coming closer to that of the center of curvature. He was far away, infinity. He is starting to come closer towards the center of curvature, that is to f1. So which means he is beyond center of curvature, which is closer to center of curvature, or beyond, little far away from the center of curvature. Now the light ray, one of a light ray will pass through the optic center. When a light ray passes through the optic center, it does not undergo any refraction, which means this light ray will travel straight in this position to like this. Okay, so make sure you take a scale from here and make it pass through the optic center and extend it. Then one more light ray will travel parallel to the principal axis. It will bend through the principal focus and then again join it at a certain point. And these two lines will join in between the focus and the center of curvature on the right side. Is it clear? If the object is beyond the center of curvature of the left side, the two light rays will converge and meet at a point between F and C of the right side, the focus and the center of curvature of the right side, which means the image is formed on the right side, and this image is formed in between the principal focus and the center of curvature of the right hand side. Okay, so you can see that the image is formed of this particular object or this person, and it is a smaller in size. Actually, it is not much easily determined in the diagram, but when you're drawing it, draw this one a little bigger and this one a little smaller. So what happens is, this is having a little smaller image than that of this one. Okay, so here what happens in this is the light rays will converge and form an image. So what you all need to do is, you all need to frame a same type of points under this diagram as well, and write as position of the object beyond C. I will write it this one for the second diagram. I will write it here. Okay, this will be beyond center of curvature, or you can write it as C1. Okay, so beyond center of curvature or C1, or also you can write it as 2F1, whichever you have marked it. So write it like that. Then the position of image is formed in between F2 and 2F2. Okay, so it is better that you all write it in full sentence, saying that between the second focus point and second center of curvature, right hand focus point or the right hand center of curvature, the size of the image, what is it? The size of the image is diminished, just diminished. It is not highly diminished, it is smaller. It is not highly diminished, it is smaller than the original. It is not highly diminished, remember, just write it as diminished. The next, it is real and inverted. Now I can really determine the nature of the image. It is real and it is inverted. You can see that this is inverted image, and inverted images are usually real image. Okay, so this one is for the second diagram, whatever I have written. I want you all to write it for all the other diagrams after I explain, and please understand the explanation very clearly. So these two I hope you all have understood. If not, please go through this, pause the video and note it down, and go through this video once again, and then come to these things. Okay, is it clear? So please check this video now.